Welcome to the Deep Dive. We're here to unpack complex topics from detailed sources and give you the core insights.
That's right.
Today, we're getting practical. We're tackling how to build a really solid e-commerce platform on AWS.
Yeah, this is a big one. We've got a fantastic guide here, very developer-focused, that lays out a conceptual roadmap.
Exactly. So our mission today, give you a shortcut, a kind of mental model for understanding the foundations of an online store that's truly scalable, secure, and cost-effective too.
Which is key.
This guide isn't just high-level theory either. It really digs into the practical design choices, the specific AWS services, and maybe most importantly, how automation fits in everywhere.
From catalogs to checkouts, it covers the whole spectrum.
Okay, let's jump in.
And right at the heart of this whole thing, the guide emphasizes the AWS well-architected framework. It's 6 pillars.
Operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability.
Got it. Exactly. And the guide insists these aren't just buzzwords you check off later. They need to be baked in right from the very beginning, from day one of planning.
So it's about building it right the first time.
Precisely. It flips the script from fix it later, which costs a fortune in tech debt, to design it resiliently from the start. It's like your compass for building something that lasts.
Okay, powerful concept. So before we even think about code, what does this guide say is absolutely critical, laying that foundation?
Right. It starts with defining requirements. Sounds basic, maybe, but this is where that well-architected thinking kicks in immediately.
So beyond the obvious functional stuff like product catalog, search, login.
Yeah, those are table stakes, user auth, cart, checkout, payments, order tracking. You need those. But the guide quickly pivots to the non-functional requirements. That's where you differentiate.
Like what specifically?
Things like supporting maybe 1,000+ concurrent users,
Yeah.
hitting that 4 nines uptime 99.99%.
Wow.
Ensuring low latency access for users everywhere, globally. PCI DSS compliance for payments, absolutely non-negotiable for card data.
Crucial.
And an infrastructure that just scales automatically. No frantic manual work needed during a sales spike.
And for the developers themselves, what do they need?
Yeah, the guide calls that out too. Automated deployments are key. A modular design, so changes in one place don't break another. And seamless CI/CD integration. It's about making their lives easier and the process smoother.
That really is a comprehensive list before you start building. So requirements locked down, well-architected principles in mind. What's the next step according to the guide, the actual architecture?
It champions a microservices-based headless architecture.
Okay, break that down a bit. Why microservices?
Well, the big idea is decoupling. You break the system into smaller independent services. Each one can evolve on its own, scale independently, maybe even use different tech if it makes sense.
More agile, more resilient then.
Exactly. Conceptually, you get these clear components. You've got your front end, a static app, users see, the back end handling all the business logic via APIs, your data layer, probably using different databases, and analytics, of course, to understand what's happening.
And the guide highlights infrastructure as code, specifically AWS CDK, to build this. Why CDK?
Right. CDK is huge here. It's not just scripting infrastructure. It's using actual programming languages like Python, TypeScript to define it.
So more power, more flexibility.
Yeah, and importantly, it lets you create modular stacks. Maybe one stack for the front end, another for back-end services, one for data.
Separation of concerns.
Precisely. It promotes isolation, makes things reusable. And you can bake those well-architected practices right into the code, like defining least privilege IAM roles within your CDK app.
Okay.
Plus, you can do an initial review with the AWS well-architected tool using your CDK structure, even before deploying anything.
Catch potential issues really early.
Very proactive. Okay, strategy set, IC plan ready. Let's talk about the user experience, the front end. What's the approach there? So the guide recommends hosting the front end as a static single-page application, maybe built with React, Vue, Angular, whatever framework you like.
And where does that live?
Directly in Amazon S3.
Yes.
Simple, durable storage. But then, crucially, you serve it globally using Amazon CloudFront.
The CDN. Why is that so important?
Speed and reach. CloudFront caches your site content at edge locations all around the world, super close to your users. That dramatically cuts down latency. Pages load faster, images appear quicker.
Makes sense. Any specific optimizations mentioned?
Oh yeah. Things like setting smart cache behaviors in CloudFront, like tell it to cache images for 24 hours maybe, and enabling newer protocols like HTTP3 for even faster connections. It's all about that snappy, responsive feel.
Got to keep those customers happy. Okay, user experience covered. But security, how do we protect this global storefront?
Security is absolutely paramount. The guide stresses building a secure network foundation using Amazon VPC, your own private slice of the AWS cloud.
Right, virtual private cloud.
Inside that VPC, you use public subnets for things facing the internet, maybe load balancers, but you keep your critical stuff, databases, backend functions in private subnet.
Away from direct internet access.
Exactly. And then layered on top, you attach AWS Way, the web application firewall, directly to CloudFront.
What does WAF do?
It's your frontline defense. It blocks common web attacks like SQL injection, cross-site scripting, bad bots. You can customize rules, too. It stops threats before they even get close to your application.
Smart. What else for security?
Free SSL/TLS certificates via AWS Certificate Manager, ACM. So everything's HTTPS, encrypted, non-negotiable these days.
Absolutely.
And using VPC endpoints. This lets your resources inside the private subnets talk to other AWS services like S3 or DynamoDB without going over the public internet at all. Keeps traffic entirely on the AWS network.
Very secure. Okay, stores up, it's secure. How do users actually sign up and sign in? Authentication.
That's where Amazon Cognito comes in. It's a managed service that handles all that user directory stuff, sign up, sign in, password recovery.
Takes that burden off the developers.
Completely. Cognito user pools handle the user directory. And then identity pools can grant temporary, limited AWS credentials to authenticated users, so your front end can securely call specific AWS APIs if needed.
And what about logging in with, say, Google or Facebook?
Yep. Cognito supports federated identity providers, so users can log in with existing accounts. Makes it much smoother for them, less friction.
That's a big win for user experience. Now, thinking about the developers again, any specific best practices for this front-end networking layer?
Definitely. For operational excellence, automating the front-end deployment, using tools like AWS Code Pipeline and Code Build, triggered maybe from a code commit repo.
So push code, it deploys automatically.
Right. Fast, consistent, reliable deployments. For cost optimization, S3 intelligent tiering is great. Automatically moves less used front-end assets to cheaper storage tiers.
Saves money without you thinking about it.
Exactly. And for sustainability, optimizing the CloudFront caching isn't just for speed. Less data transfer means less energy used. It all adds up.
It really is a holistic view. Okay, fantastic. Storefront is welcoming, perimeter is secure. Let's get into the brains, the backend, the API layer. How does the guide tackle that?
It strongly leans towards a serverless architecture for the core backend,
Meaning?
using Amazon API Gateway to create and manage your RESTful APIs. These are the endpoints your front end calls for, things like getting product details or adding to cart.
Okay, the API front door and the logic behind it.
That's handled by AWS Lambda functions. You write your code, Python, Node.js, Java, whatever, for each microservice, like process order or update inventory. Lambda runs it without you managing any servers.
Auto-scaling, pay-per-use, the usual serverless benefits.
Exactly. Simplicity and scalability. Though the guide does mention an alternative. If you prefer containers, you can use Amazon ECS with Fargate. Still serverless, you manage containers, not servers.
Good to have options. Now, with all these microservices potentially calling each other, how do you ensure things don't grind to a halt if one service gets slow? Reliability?
Great question. The answer is asynchronous processing, primarily using Amazon SQS Simple Queue service.
Queues, how do they help?
They decouple your services. So when an order comes in, the main checkout service doesn't have to wait for the email confirmation to send and the inventory to update right now.
Okay.
It just quickly drops messages onto different SQS queues, one for email, one for inventory. Then other dedicated Lambda functions pick up those messages and process them reliably in the background at their own pace.
So the checkout stays fast and the other tasks still get done eventually.
Exactly. It builds resilience. If the email service is temporarily down, the messages just wait in the queue. The orders aren't lost. It prevents cascading failures.
That definitely sounds like something engineers would appreciate. All right, let's talk money, the payment flow. How does that work securely?
The guide suggests integrating a third-party provider, like Stripe or PayPal, typically via a dedicated Lambda function.
Why a dedicated function?
Security and isolation. The key is secure tokenization. The sensitive card details go directly from the user's browser to the payment provider. Your backend only ever handles a secure token representing that transaction.
So the card data never touches your servers, reduces PCI scope.
Precisely.
Yeah.
And for keeping customers in the loop, order confirmations, shipping updates, Amazon SNS, Simple Notification Service, is great for sending out those notifications via email or SMS.
And securing things like API keys for that payment provider.
AWS Secrets Manager. You store sensitive credentials there, encrypted, and grant your Lambda functions tight IAM permissions to retrieve them only when needed. No hard-coding secrets in your code.
Good practice. What about finding products? Search is critical in e-commerce.
Absolutely. The guide recommends Amazon Open Search Service for that. It's built for indexing large catalogs and providing fast, relevant full-text search with features like filtering and suggestions.
And maybe personalization based on search.
Yeah, Open Search can definitely be the foundation for building recommendation engines too.
Okay, pulling it all together for the backend. How do the well-architected pillars show up here?
They're woven throughout. Security, those least privilege IAM roles for Lambda, reliability, API gateway features like caching frequently requested data, and throttling to handle traffic spikes gracefully. Operational excellence, using CloudWatch logs for detailed logging from Lambda and API gateway, and AWS X-Ray for tracing requests across multiple microservices to find bottlenecks.
Essential for debugging distributed systems.
Totally. Cost optimization. Lambda's pay-per-request model is inherently cost-effective. And sustainability. Serverless services scale up and down efficiently, minimizing wasted compute resources and energy.
Makes sense. Okay, let's shift to the data layer, the memory of this whole operation. Sounds potentially complicated. One database to rule them all.
Definitely not. The guide stresses polyglot persistence, using different databases for different needs. Recognizing that different data has different shapes and access patterns. So for things needing high throughput, maybe flexible schema like shopping carts, user sessions, maybe even product catalogs. Sometimes it suggests Amazon DynamoDB, the NoSQL database, often using on-demand capacity so it scales automatically.
Okay, NoSQL for flexible, high-volume data. What about orders, inventory?
That's usually more structured transactional data. There, it recommends Amazon RDS, running something like Aurora PostgreSQL or MySQL relational databases, and using read replicas to scale out the read load.
Right tool for the job again. Where do product images and videos fit?
Classic use case for Amazon S3. Store the media files there. And use S3 lifecycle policies to automatically move older, less access files to cheaper storage tiers like S3 Glacier Instant Retrieval or Glacier Flexible Retrieval to save costs.
Smart cost optimization. Now, performance is key. How do we speed up access to frequently needed data without hitting the main databases constantly?
Caching. The guide brings in Amazon Elasticache, usually with Redis.
How does that help?
You put Elasticache in front of your RDS or even DynamoDB for certain things. It stores copies of frequently requested data like popular product details or user profiles in super-fast memory.
So requests hit the cache first?
Exactly. If the data's there, boom, instant response. It dramatically reduces load on your main databases, improves response times, and makes the whole user experience feel faster. It's a huge performance win.
Definitely sounds like it. And data safety backups, recovery?
Absolutely critical. The guide emphasizes using the built-in automated backup features for both DynamoDB and RDS.
Like point-in-time recovery.
Yes, so you can restore your database to a specific second within your backup retention window. Vital for recovering from errors. And for high availability, especially for RDS, running in a multi-availability zone configuration.
So if one data center has issues,
It automatically fails over to a standby replica in another AZ with minimal interruption. Keeps the store running.
very important. Okay, we have all this data stored safely. How do we actually learn from it, turn it into insights?
That's the analytics piece. The guide suggests using Amazon Athena to directly query data stored in S3, like CloudFront access logs, or maybe even order data exported to S3.
Querying logs directly.
Yeah, Athena lets you use standard SQL to analyze potentially huge log files without needing to load them into a database first. Great for understanding user behavior, traffic patterns.
And for visualizing trends, sales, inventory.
Amazon QuickSight. You connect it to your data sources, RDS, Athena, S3, DynamoDB, and build interactive dashboards. Makes it easy for business users to see what's happening and make informed decisions.
And underpinning all this data stuff, developer best practices.
Always. Things like AWS KMS for encrypting data everywhere, at rest and in transit. Using those VPC endpoints again for private secure database access, maybe AWS Glue for ETL if you need to transform data for analytics. DynamoDB on-demand mode supports sustainability by scaling efficiently and constantly keeping an eye on costs with AWS budgets and using tools like Compute Optimizer to make sure your RDS instances are right-sized. It's all part of managing that data layer effectively.
Building it is definitely just the start. The guide really emphasizes that this is a living system, continuous optimization, monitoring, iteration.
Absolutely. It's never done. You need to keep evolving it.
So what are the core recommendations there for keeping it healthy?
Auto-scaling is fundamental. Configuring it properly for Lambda and ECS ensures you can handle traffic surges smoothly without paying for idle capacity during quiet times.
And watching everything.
Amazon CloudWatch is your eyes and ears, monitoring key metrics, latency, error rates, resource utilization, setting up CloudWatch alarms to get notified immediately if something looks wrong.
And for digging into problems in that microservices world.
AWS X-Ray is incredibly powerful there. It lets you trace a single user request as it travels through API gateway, Lambda functions, maybe even down to DynamoDB. You see exactly where time is being spent or where errors are happening, essential for debugging.
That visibility sounds crucial. Now, zooming out slightly, how does the CI/CD pipeline fit into this continuous iteration?
It's the engine driving it. The guide talks about using the AWS Developer Tools code pipeline for orchestration, code build for building and testing, code commit or another Git repo for source control.
And it automates everything.
Pretty much. Code changes trigger the pipeline, which builds, tests, and deploys not just the application code, but also the infrastructure changes defined in AWS CDK. It makes deployments fast, repeatable, and much less risky. It's pure operational excellence.
Makes sense. And thinking long-term, global reach, cost, security, what are the ongoing considerations?
For global resilience, Route 53 latency-based routing is key. It directs users to the AWS region closest to them, providing the best performance. Combine that with multi-region S3 replication for critical data for disaster recovery.
Covers the DR scenario, costs.
Ongoing vigilance, using AWS budgets to track spending and get alerts. Looking into savings plans or reserved instances for predictable workloads on EC2 or Lambda to get significant discounts.
And security isn't a one-time thing either, right?
Definitely not. Regular audits are essential. Using AWS Config to track configuration changes and ensure compliance with your security policies. And leveraging AWS Trusted Advisor for automated checks across cost, performance, security, and fault tolerance.
Okay, and tying it back to sustainability one last time. And the well-architected framework.
For sustainability, the guide points towards using AWS Graviton processors, ARM-based chips, for services like ECS or RDS where possible. They offer better performance per watt, lowering energy consumption.
Good tip.
And crucially, the well-architected framework isn't just for the initial design. You need to conduct regular well-architected reviews after deployment. Use the well-architected tool, maybe monthly or quarterly.
Why? What does that do?
It helps you identify areas where your architecture might have drifted from best practices over time, or where new AWS features could offer improvements in cost, performance, or security. You can even use CDK assertions locally to test infrastructure code before deployment. It keeps the system aligned and optimized. It's that continuous improvement cycle.
Wow, what a comprehensive journey through building an e-commerce platform on AWS guided by this source. We've really seen that structured, developer-centric approach.
Yeah, from the initial planning, really focusing on those requirements.
All the way through deployment, operations, and that continuous optimization loop. And always, always guided by those well-architected pillars.
It shows that a robust online store isn't just features, it's deep architectural thinking. Affects everything: speed, security, cost, resilience.
Absolutely.
And the core message from this guide really is about building something inherently scalable and secure, but also optimized for the developers building and running it through automation, solid monitoring, and just sticking to those best practices.
It feels like a real blueprint for avoiding common problems and building for the long haul.
Definitely. Build something resilient.
So, for you, our listener, what does this all mean? Here's a thought to chew on. How could applying these pillars, operational excellence, security, reliability, performance, cost, sustainability, and this whole iterative, well-architected mindset, how could applying that to any complex system you work on, not just e-commerce, fundamentally change how you design it, how resilient it is, and its success over time?
It's a powerful lens for system design, truly universal.
Definitely something to think about. Thanks for diving deep with us today.
Yeah, thanks everyone.
We'll catch you on the next deep dive.